Okay, here's our last one of the year 12.8 in Reveal Geometry here. We're going to be talking about two-way frequency tables. So these warm-up questions are actually a good kind of segue into this. But it says we're going to organize the data it talks about in a two-way frequency table. So in 2013, so it's giving me a year, downloads of apps were 81.42 billion. Of those, 73.28 billion were free and the rest were paid. The previous year, downloads of apps were 45.62 billion and 40.60 billion were free. So it looks like we have paid versus free and we have years, okay? And it doesn't matter which order you do this in. You can do free and paid on the top and the years. So let's see, it said the previous year. So we're going to say 2012 and 2013. But again, if you did 2012 and 2013 on the top, that's fine. Free and paid on the side, it's up to you. But this is kind of what we have here. And so then we're going to go through, and in 2013, downloads apps, it gives us the total. So you can also do totals on the outside. So we can see this would be 81.42 billion. Of those, 73.28 billion were free. So we're going to do 73.28, and I'll come back to that number there. And then it says the previous year downloads of apps were 45.62 billion. So we're going to go 45.62 out here with 40.60 billion free. So 40.60. And then you can solve for the other pieces. And this is the part that you're going to kind of work through today. But if you know the total and you know this part, you should be able to find paid by subtracting those. So it's 5.02. Same thing down here in 2013. Subtract those. You get 8.14. You should also be able to total up your free and your paid. And so if I add these together, I have 113.88. And if I add these paid ones together, it's 13.16. And lastly, you should be able to have a grand total, which would be over here. And for this one, it's 127.04. For the grand total, you can either add your 2012 and 2013 or your free and paid to get that number. So that's how you make a two-way frequency table. And then we can answer the question, how many paid apps were sold in 2012 and 2013? So those would be our answers there based on that. Okay, so that's our two-way frequency table for that. Doing another example of that, in a recent survey, 502 men reported they play video games. So we have men, we have video games. Of those, 154 refer to themselves as gamers. Of the women asked, 482 play video games, with 58 of those referring to themselves as gamers. So I think we're going to have gamers and not gamers, and we're going to have men and women. So again, it's up to you how you want to do this. I'm going to throw my men and women over here. And then on the top, I'll do gamer and not, and kind of split everything here a little bit. I think that makes sense. So then if we go to 502 men, so there's my total for men would be way out there. That they play video games. Of those, 154 refer to themselves as gamers. So 154 goes here. And then women asked 482 play video games. So 482 are out here. 58 of them would consider themselves gamers. So that's what we have to fill in. Then I can... There's a lot of people. Okay. Then I can subtract. Sorry, I don't know where my calculator is. So you could subtract those and find and fill in your different pieces that are here for each of them, just like we did up there. Okay, let's go ahead and keep going then. Okay, so a two-way frequency table is like what we just made here. Okay, also called a contingency table. You're going to see it this way a lot more. Is used to show the frequencies of data from a survey or experiment classified according to two variables, with the rows indicating one variable and the columns indicating the other one. And it doesn't necessarily matter which one's which. The two-way frequency table shows the results of a survey of 220 men and women about the time of day that they shower. So shower in the morning versus shower in the evening, men and women. You can kind of read that. The frequencies reported in the totals row and totals column are called marginal frequencies. So out in the margins, you have how frequent those answers are, with the bottom rightmost cell reporting the total number of observations. Marginal frequencies allow you to analyze with respect to one variable. For example, the marginal frequency in the right column separate the data by gender. So if we wanted to say how many women were surveyed, you could just do 135 out of 220 there. That would be a marginal frequency. Or you could just say how many people said they shower in the morning. So again, that's a question that doesn't have anything to do with this other variable that's here. The frequencies reported in the interior of the table are called joint frequencies. So these show frequencies of all possible combinations of a category for the first variable. So if I said how many women shower in the morning, you could say 98 out of 220. So that would be a joint frequency there. A relative frequency is a ratio of the number of observations in a category to the total number of observations. So what you see there, 98 out of 220, you can see actually in a two-way relative frequency table here that shows the probabilities of each of these things happening. Okay, so you see my 135 out of 220 that was there, and my 98 out of 220 that I found. But those are relative frequencies. Okay, ratio of the number of observations in a category to the total number of observations. When survey results are classified according to variables, you may want to decide whether these variables are independent of each other. Variable A is considered independent of variable B if the probability of A and B is equal to probability of A times probability of B. So yesterday we actually talked about independence, and we talked about the fact that if the probability of A was equal to the probability of A given B, that we know that we're independent of each other. Well, this is another way to find independence. And it doesn't matter which way you do, they both will come out to the same idea. But those are your two different ways that you could find independence of each other. Especially when there's something like this, it can be a little confusing as to whether they're independent or not. So you want to use the rule. Okay. So an example here with school. So we have some information about a physics test here. Sorry, I just got to find mine. There it is. So immediately after physics test, the entire class sits together at lunch and discusses how long each of them studied and how many questions they guessed on. The table shows the responses from their classmates. So guessed on less than 5 problems or more than 5, and then studied 4 or less hours or more than 4 hours. So true or false, for these classmates, guessing on more than 5 problems, on the physics test is independent of studying 4 or less hours. So we want to figure out the probability of A. So this is going back to this guy down here, and we're going to do it with the new one. So A and B is equal to probability of A times the probability of B. So I'm going to rewrite that here. A and B is equal to the probability of A times the probability of B. This is what we want to figure out here. So what we're going to do is the probability of A and B, 4 or less hours and guess this many would be only 3 of them. So it'd be 3 out of 28. And we want to figure out if that's equal to, so probability of A, so guessed on greater than 5 problems are 7 total, so that would be 7 out of 28, times the probability of B, studied 4 or less hours would be 12 total, so that'd be 12 out of 28 that you're solving there. And if you find, let's just make sure that I have all the correct information here. Yeah, and if you find those, you're going to find that they are not guessing is independent. So these are dependent on each other because these are not equal to each other. When you multiply those out, they are not equal to each other, and thus these are not dependent. So we're going to say false in this case. Sorry, the false, true, or false threw me off there. So these are dependent on each other. Okay, so checking that independent versus dependent. Okay, so you have your page 767, number 1 through 7 odd to do here.